Hi there and welcome to another C# tutorial, and this time we're going to be looking at variables. Yay! So here we are back in the Unity editor, and what we're going to be looking at today is variables. Now you may have seen variables on various game objects where you can adjust certain values, and these are essentially variables. And technically a variable is a tiny section of your PC's memory that's reserved to hold some data. And you can think of variables as a container. They can hold stuff, you can adjust what they're holding and move them around. And even empty containers can be useful. So what I'm going to do here is I'm just going to create a script in my scripts folder, and I'm going to call it variable script. And then I'm going to double click it and open it up in Visual Studio. So in our last tutorial, we went over the structure of a script and what all these individual components are. Now for our variables, you normally find your variables all declared at the top of your class declarations. After the curly brace, there'd normally be a line, and here's where you would put your variables. So variables have to be declared according to certain rules and requirements. Each variable must have the type of data that the variable will store, has to have a unique name, needs to end with a semicolon, and if you assign a value to it, it must match the specified type. So what do we mean by this? Let's do a very quick example. Let's make a variable, and we're going to make it of type int. It's a number, an integer, a whole number, and it can be, let's call it player health. Now this would declare a variable, okay, and it would declare a variable of type int, and its name is player health. And you can see here I've used camel case, and the way you normally write a variable is with a small beginning letter, and then using camel case, anything after that, in additional words will be with a capital letter. Now, if I wanted to give this player health like a default value, I would say equals 10, and that would be absolutely fine. Now, player health would be equal to 10. So when we start our program, I'm going to put a quick debug message in here, and we're going to display the player health and save it quickly. We'll create a quick game object. We can just leave it named as game object. We're going to drag our script onto that. You're going to see it's popped up here. We've now got our variable script as a component on game object. We can hit play. And you can see here we've got 10 in the inspector. In its simplest form, we've declared first variable. It's of type int, and it's player health, and it's equal to 10. So we have our data type here, and then the variable name. Now this is a whole number. You can also have a float, which is going to be a decimal point number. And let's say we wanted to make player experience, so we could use camel case again and type in our variable name. And if we wanted to give it a default value, we would say we had 120 experience points. Because it's a float, we have to add the F onto the end of the number and then end our variable declaration with a semicolon. And then if we wanted to see what the health was, do another debug message in our console, player experience. We could also have data type of string. So this is going to be characters. Maybe we could say player name, and let's say we want to call it level up. And you create strings using the quotation marks either side, and then put any characters you want to assign into that string in between the two speech marks. Then we'll copy this, debug log, and we'll print off our player name. And then the last data type we're going to have a look at is the bool, which is a boolean. It's a true or a false. So to declare one of those, we can say bool. I normally start my bools with an is in the name. I would say is player alive. I can set that as a default value to true. And once again, we'll debug that so we can see it in our console. So we have these are the 4 most common data types in C#. Int, which is integer, float, which is a number with a decimal place, string, which is some characters, and bool, which is a boolean statement, it's true or false. But it is also important to understand that literal values such as numbers and words aren't the only kinds of values a variable can store. For example, you can store classes, structs, enumerations, and this is really going to allow you the freedom to create whatever you need. But for now, we're just going to look at the 4 main types. So now we've got all that set up, we're going to write it all to our console. Let's have a look and see what happens when we hit play. So we've got the script assigned to game object. Let's go ahead and run this again. Now you can see we've got all our variables that we declared. We've got our integer of 10, our float, which is 120, that was our experience points, the player name, and are we alive or not. It's written all those variable values to the console. And we can go ahead and make this a little bit more readable for us. We can improve our debugs. We can go ahead and print a string to our console, and remember to start using strings. We're going to need our speech marks, and then we can say here player health equals and a space, and then we'll do quotation marks to finish off, and then we want to put a plus player health. And we'll do exactly the same for the other ones. Now when we run this in our console, let's go ahead and make this even clearer. Let's call this game object player. And let's pretend the variable script was containing all the data for the player. Go ahead and clear our console. And when we hit play, we can see here now we've got player health equals 10 and player experience, I spelled that wrong, equals 120. Player name is level up and player alive is true. So those are our 4 main data types. Remember, you can pretty much have your own ones there, or your own classes, structs, enumerations. But these are the 4 main ones. But what happens if you want to see these in the inspector? If you go back to Unity, remember with your scripts, you might want to adjust these variables and have be altered in the inspector. Now, we can do that in a couple of ways. What we're going to look at next is access modifiers. And there are 4 main access modifiers available in C#. They are public, private, protected, and internal. There are a couple more, but those are the main ones you're going to be using the majority of the time. So if we were to set all these variables to public, so I'm going to copy that, I'm going to paste it here, and I'm going to paste it here. So this will now make the variables available for adjustment in the inspector. That isn't exactly what the public keyword is saying. What we're saying here is that player health is now accessible by any script in our application with no restrictions. If we go back now to our to Unity, we can see here we now have access to change any of these variables. We can say, actually, we want our player health to be 5,000 and our experience to be really low, and let's say we call this Dan, and the player's dead. And when we hit play, we've now got those variables that we've typed in. This has overridden the values that we have stored as our default values. So that makes them, the public keyword is going to make your variables accessible to any script. But what about if we didn't want any script to have access to them? We just wanted this class, this containing class of variable script to have access to these variables. Then we would need to change our public keyword private. Let's say we make the player health and the player experience. We don't want to give access to these 2 variables to any old class. Then by giving them the keyword of private, it's going to mean that they're only available here in this containing class. So saving that and then going back to Unity, you can see here that they've now removed themselves from the list, but they still exist. Still there. See, we've still got player health, player experience. And what's important to note is that by removing the private keyword, the variable declarations here will by default become private. You don't actually need the private keyword. Sometimes it helps for readability and understanding what's going on, and that's something you'd have to agree with in your development team. But just to throw a quick spanner into the mix, let's say we wanted to keep our private variables private, but we still needed to be able to tweak them in the Unity inspector. Well, there's a way around making them visible in the inspector, and that is to make them a serialized field. And by doing so, then makes that value appear in the inspector, like so. But this still won't be accessible by any other classes. So there are 2 other access modifiers. There is the protected, and this is going to make our string player name accessible from our containing class, which is variable script, or any other classes that are derived from variable script. So if we were to make a new script and it inherited from variable script, so let's say for instance we wrote a script and instead of mono behavior we typed variable script at the top, then we'd have access to the string player name. And then one I don't use too much, but still available, is the internal. And what we're saying here is that is player alive is now only available in the current assembly. I don't tend to use that very much. I mainly tend to use private and public variables, but you can go ahead and you can look up some more information on those. So those are our access modifiers. Let's just remove that a second just to make it a little bit easier for you to see. So private, protected, internal, and public, all access modifiers. And you might have heard of a term called encapsulation on different tutorials, and all encapsulation means is defining how accessible an object's variable and methods are to outside code. So by making these public and private, this is all encapsulation. There is another variable type that I use quite a lot, and C# has the ability to do something called inferred declarations. And what that basically means is that, let's say for instance we're in the start method and we want to create a variable. We could use the keyword var, and we could say var new player health, and we could say that could equal player health minus 20. Now if you hover over new player health with the mouse, you can see we have here below that the local variable is a type int, so this is now become an int because of the parameters we've given it here. So that's another way of creating a variable, and that's known as inferred declaration. And this var is very handy, but you have to be careful in their use because the code can be hard to read and follow by using the var too much. So then, just to summarize, a variable is a tiny section of your PC's memory that is going to hold a value. And you can think of variables as like a container that you can fill them with stuff, adjust what they're holding, move them and reference them, and even use empty variables. And you must remember, names with variables are very important. Each variable that we create must have a unique name, and a variable will normally consist of an access modifier, a data type, the name, and any value that you assign to it. Well, that's it for this week's tutorial. Next week we'll have a look at methods. See you then.